I'm here in Barcelona at Mobile World Congress. We're in the Dell booth, and I'm sitting here with Nick Lemieux, who is Red Hat's chief architect for NFV and ICT. And Nick, you have a presentation to show me here, right?
So what we see here is, what NFV. So basically, NFV is really looking into the traditional infrastructure and telecommunication. That infrastructure was pretty vertically integrated. So basically, hardware was, tightly coupled with hardware. And basically, those products were appliances. So it made things pretty hard to do deployment, to do integration, and really NFV is a framework that proposed to use standard IT architecture, to handle those applications. So in IT, hardware is decoupled from software infrastructure from application. So on the right side, this is a little bit what I wanted to illustrate, where we leverage virtualization, we leverage cloud type, practice to basically deal with those applications. Obviously, by taking this approach, like it's been proven with IT, increased flexibility, right? So now you got API to be able to manage, those different components. Lower cost, ability to leverage CUTS hardware, so Intel type hardware with community of the shelf storage and networking. Dynamic scalability, so obviously with cloud, with virtualization, easy to scale out, easy to scale up. So that brings basically another benefit. Open source, in our case, bring lower innovation risk, lower innovation cost, and future-proof basically offering. And finally, with all those API, with the decoupling of all those components, business agility is now available. Where before it was really operational and manual. So if we look here, this is the reference architecture for NFV. There's a standard at C, ISG NFV, which is an industry standard that hosts where those different components are defined, the interface between those components. So if we start at the bottom, we have the NFV infrastructure, so Network Functions Virtualization Infrastructure. This is really the runtime. This is where software meets hardware. This is where basically the capability to do compute, network, and storage is happening. And on top of this, what is called here virtual network functions, those are the applications. So traditional application like an evolved packet core, an IP multimedia subsystem, a content delivery network. Those are traditional applications, but deployed with virtualization. On top of this, operating support system and business support system are what is in place today in the operator that allow them to do business, that allow them to provision those networks. One of the big new components, I think part of the equation is on the right side, what is called management and orchestration, or MANO. There's three components to it. One deal with the end-to-end service configuration. So basically the ability to look at, let's do voice, for example. Before voice had multiple components that had to be configured, that had to be provisioned. It would take months to deploy new voice service. Today with this proposal, with a couple of clicks, it's possible to literally, in a couple of minutes, be able to establish voice. So you got a new subscriber in a house, a new device to plug his internet service, and now easily you can establish his voice service in a couple of clicks and be able to manage it. There's also a piece that deals with the life cycle of those applications. So basically the ability to deal with failure and scale out, which were not there before, now are possible. And the reason why it's possible is because of the third component, which is called Virtual Infrastructure Manager, which is what basically make the infrastructure accessible into API and make it either provisioning can be done through API, failure management. So basically everything that deal with hardware, compute, storage, and network can now be done through clicks. Right? Obviously, through this proposal, the demand we see in the market with the operator, which is key to us, openness. So open system, open interface, and open software. So this demand is at 83%, part of the carrier, and also basically open source. So basically leveraging open source software and leveraging innovation done in those community to basically extend capability. So basically fast innovation, powerful think tank, and choice of vendors. OP-NFV, Open Platform NFV, is actually pretty interesting. So it's a little bit different than traditional telecom, approach. Before, standard body would take care of all the interface, all the requirements, the specification. Vendor would get it, would turn around over 2-3 years, implement their products to meet those standards and those requirements. So there was not really like a feedback, not a way to try out and test things. So with NFV, the operator worked with Linux Foundation and literally did an open source project for NFV. It's called OP-NFV. And the intent of this project is to build a real reference platform out of open source software. So basically, go get the building blocks, build a platform so that things can be tested. Things can be extended. We can learn lesson, develop best practice, and use it as a feedback into the standard and the specification, so that there's a continuous, kind of feedback to make sure that standard is really aligned with what's possible and what can be built, and provide a faster time to market. So obviously through this, open source being so key, Red Hat is at core an open source company. And some of the key projects, right, part of the reference platform that I mentioned, Open Daylight. So Red Hat is a platinum member and board member of Open Daylight, which is an SDN controller project. OpenStack is what is seen as the core platform for NFV. So when we talk about the NFVI, the Vim, those are enabled in 90% of the case by OpenStack. So OpenStack is an open source project, one of the largest to date. And again, Red Hat is a leader, developer, and contributor into OpenStack. And finally, Linux Foundation. Everything NFV at core start with Linux and kernel. This is a key requirement. So Linux Foundation is key, also being the sponsor for OP-NFV. So if we literally look at the diagram I showed before, where we had the reference architecture and the different components, here what we can see is the same diagram overlaid by Red Hat products. So you can see Red Hat serve many building blocks, starting with basically the compute piece, the virtual compute. At the host, obviously, Red Hat Linux. As a guest, KVM, right? Kernel virtual machine is also a key piece for virtualization when used. From a virtual storage perspective, we have Red Hat Storage, which is built up of Gloucester FS and Ceph, which are file-based scale-out software storage, and Ceph is a block scale-out software storage. So we have a proposal there. We can also leverage, in the OpenStack case, vendor plugins to basically integrate hardware appliance for storage like EMC and NetApp and so on. From a virtual network perspective, by default, we would propose OpenStack with Open vSwitch, which is an open source project for vSwitch, and also Open Daylight, to basically have plugin to integrate physical network infrastructure. As we move on top, from a guest OS perspective, again, Red Hat Linux is the platform of choice, hardened, really stable and mature. And on top, as we start looking into the application space, we have other offering around middleware with Red Hat JBoss. We have also PaaS offering with Red Hat OpenShift, we have basically a full stack, if you want, to offer from an NFVI and a VNF perspective. On the Mano side, really, like I mentioned, at the virtual infrastructure management piece, again, Red Hat Enterprise Linux OpenStack is the core piece that enables Vim. And in some cases, we can also leverage a product called Red Hat CloudForm, which is a cloud management platform that allowed to bring efficiency on how to operate OpenStack and other virtual infrastructure like VMware or KVM. So all this is kind of the Red Hat product mapping, and all this is also backed by a really strong ecosystem, which is really key with NFV. There's no one vendor that can deliver a solution like that. Really complex, many moving parts. So from a Red Hat perspective, we work with all the vendors in the space, large, small, and basically most of those vendors typically would be really good in some specific virtual function piece or in the management and orchestration piece. But at the end, we have a certification process that allows us to certify also the hardware. So compute vendor, storage vendor, network vendor. You can see a snapshot here of some of the vendor with who we are extremely active. And from a VNF perspective, company that do network equipment like Nokia, like Alcatel-Lucent, are the largest vendor, but we also work with smaller independent software vendor like Brocade, Mavenir, and so on, depending on the case, the use case they provide. On the management side, as you can see, we have also a rich set of vendors that come and basically wrap up this whole end-to-end solution. So from our perspective, this is our ecosystem play, and we have a certification program basically to support NFV.
Great. Well, Nick, thanks so much.
It was my pleasure. Thank you for having me.